from this channel. Today I will be discussing about another function which is divisor function. Divisor function is a part of number theory and also it can be a part of algebra also and functions. As we are dealing with functions presently in various lectures till now, we have been dealing in the various types of functions, polynomial functions. In the last lecture we have discussed. In this lecture we will be discussing a divisor function. A divisor function is a function. It denotes the number of divisors of n. Dn is equal to number of divisors of n. This can also be denoted as tau n. That is the divisor function. Number of divisors of n, integer n. Now, here the integer given is 999 to the power of 999. Very large integer, which you cannot do manually. That means we have to apply certain algebraic rules, certain function rules, and also certain number theory rules, congruence modulo, which I have discussed in the previous classes. Please refer to my previous lecture on congruence modulo. And these functions is a very vast subject. We have done two numericals on polynomial functions. I want to introduce you to different types of functions in addition to the regular functions, that is exponential function, logarithmic function and linear functions, polynomial functions. I want to introduce you to a divisor function which is also an algebraic function. It is given in IIT JEE or JEE Mains or Advanced. The syllabus is algebraic functions is also there. If we count on it without any further expanding on that particular syllabus sentence, we can say a divisor function can also form an algebraic function, even though it's a part of number theory. Real valued function, it is rather called real valued function. It's a real valued function, divisor function. Now, what we have to find out? We have to find out the number of divisors of integer n. Now, how to do it? Now, let us see. It's a very good example. What we have to do is 11a plus 111b, 111b is equal to number of divisors in 999 to the power of 999. As the domain of this divisor function are positive integers, we can say it is a discrete real valued function, because positive integers cannot be a continuous function. We can call it as a discrete real valued function. It's a real valued function. Hence I have taken this real discrete function as one in, at least I thought, let me explain at least one lecture on divisor functions in the functions theory. Now, we have to find out the number of divisors in 999 to the power of 999, 999 to the power of 999. It's a very huge number. That number is given 11a plus 111b is equal to that number. Once you know this number only, we can know about the equation. Once you know an equation and it has two variables and a single equation, solving for integers, a plus b is equal to how much? It is a Diophantine equation. It can be also a Diophantine equation. That means a Diophantine equation concept, a divisor function concept, a real valued function concept, and number of divisors in an integer when it is given concept, that is also clarified in this particular lecture. It is a lecture of multiple concepts. Please pay attention to it. Please try to understand each and every concept so that this type of question or a partial part of this question is also given. This type of questions is given in your examination. You will be able to answer them with confidence. Try to understand the concept and apply them wherever you can. Now let's move further. What is the question given? Question is 11a plus 111b is equal to number of divisors in 999 to the power of 999. Then find a plus b is equal to how much? Solution. If you see 11a plus 111b, even 11 is not factor for both. 111 cannot be divided by 11. Hence both are different, 11a and 111b. And that is equal to, it is not given. What is its value? It is given as we have to find out the number of divisors in 999 to the power of 999. Now, number of divisors in any number. If n is there, a number, it has got a number n1 into an integer n2 into an integer n3 to the power of p to the power of q to the power of r, where n1, n2, n3 are smallest prime factors for this particular number. SPF. SPF is the smallest prime factor. I have already explained this in my previous lecture. Smallest prime factor. Please see that video or lecture to understand better. Now, for example, 12 is there. 12 is equal to 2 into 2 into 3. 2 is the smallest prime factor. 2 into 2 is 2 square into 3 to the power of 1. Here this value is n1 to the power of p. This value is n2 to the power of q. When it is like this, then number of divisors is equal to, please remember this, number of divisors is equal to, if it is in this form, p plus 1 into q plus 1 into r plus 1. For 12, how many number of divisors? 12 is equal to 2 to the power of 2 into 3 to the power of 1. That implies number of divisors will be this 2 and this is 1. Powers only we have to take. 2 plus 1 into 1 plus 1. How many are there? 6. Number of divisors in 12 are 6. Because we have to convert the given number into powers of smallest power factors. Are you able to follow number of divisors? If any question is given in Maths Olympiad or IIT JEE Mains or IIT JEE Advanced, the number of divisors of a number can be found out by finding the prime by doing the prime factorization and by writing it in the form of small prime factors, and then the powers of the small prime factors will be added, one is added to all of them and they are multiplied. In this particular question, 999 to the power of 999 that is given, implies 999 number of factors we require. 999 prime factorization. Let us say, first let us do prime factorization. 999 prime factorization yields you 999 is equal to 9 into 111, that is equal to 9 into 3 into 37. 3 into 37 is 111. That is equal to 3 square into 3 to the power of 1 into 37. That is equal to 3 cube into 37. Because 37 itself is a prime number. 3 is a prime number. This is prime number 1. This is prime number 2. They are the smallest prime factors. Now, the given number is 999 to the power of 999. That will be 3 cube into 37 whole to the power of 999. That is equal to 3 to the power of 3 into 999 into 37 to the power of 999. Then it will be equal to 3 to the power of 3 into 999 is how much? Just check up. 2997 into 37 to the power of 999. When you do the prime factorization, this process is called as prime factorization. When you do the prime factorization, the smallest prime factor P1 is equal to 3 and second prime factor is two small prime factors are there. They are 3 and 37. Then what is the equation for number of divisors? Number of divisors of n is equal to n1 plus 1 into n2 plus 1. That is equal to n1 is 2997 plus 1 into n2 is 999 plus 1. That is equal to 2998 into 10,000. 990,000, sorry, into 1000. 999 plus 1 is 1000. That is equal to number of divisors of 999 to the power of 999 is equal to 2998,000. That means the given equation is 11a plus 111b is equal to 2998,000. Now what we have to do is to find a and b. It's a Diophantine equation. Diophantine equation. It's a Diophantine equation. Now we have to find out the values of a and b in this Diophantine equation. Let us say 11a plus 111b is equal to some c. Let us say that implies or else we can even rather say, instead of this, we will say a plus b is equal to some c. That implies a is equal to c minus b. That implies 11 into c minus b plus 111b is equal to 2998,000. Do you agree? That means 11c plus this 100 from 111, if you remove 11, what will be the answer? 100b is equal to 2998,000. That implies 100b is equal to 2998,000 minus 11c. Because it should be an integer. This value to be an integer. Because b we wanted as an integer. This implies it should be divisible by 100. That means in this equation 11b is equal to 100b is equal to 2998,000 minus 11c. 2998,000 is already divisible by 100. Hence, it implies 11c to be divisible by 100 100 for b to be an integer. Hence this whole equation that a plus b is equal to c. Can we write it as that is equal to 100 into some k, because it should all 11c should also be divisible by 100 and 2998000 is already divisible by 100. For b to be an integer, we can say here, if you see the GCD of 11 and 100 is equal to 1, which implies C should be divisible by 100, because in 11C what is there? 11 is not divisible by 100, then C should be divisible by 100. 11C should be divisible by 100. It implies C should be divisible by 100. That means what we have assumed previously, A plus B is equal to C. That should be equal to some 100 into K, let us say, because it is in multiples of 100 only C will be there. That means A plus B has to be some 100 into K. This is another concept we have developed, or another equation obtained from the given conditions. Now, what we are required to find out? A plus B. That means we have to find out C value, which is 100K. That means we have to find out K value. Question is to find A plus B. A plus B is equal to how much? A plus B is equal to 100K. This is what is given under the above conditions. Given these conditions, then what will be the value of K? That implies K is equal to how much? Decides about A plus B. Now, we have to find out the K value. Now, similarly, when you talk about B is equal to C minus A, when we use what happens? Or we can even say another, what is given in the equation? 11a plus 111b is equal to 2998,000. This also we have to use this one condition. We have got 11a plus 111b is equal to so and so. That means 11a is equal to 2998,000 minus 11a. Minus 11b, sorry, it is 11b. Minus 111b. That implies a to be an integer. Hence, 2998,000 minus 111b should be divisible by 11. Hence, we have to find out, which implies find mod 11 of 2998,000 minus 111b. 111 is equal to equivalent to 1 mod 11, and 2998,000 minus 111b mod 11 we require. You please connect these two. This will be 2998,000 minus b mod 11. 2998, when it is divided by, when 2998,000 is divided by 11, what happens? 2998,000 divided by 11, what happens? 5 will be the remainder. Here the remainder is 5. The small things, small arithmetic problems, you please handle. This implies 5 minus b mod 11. 5 is the remainder here, which implies when 5 is the remainder, 5 minus b equivalent 0 mod 11. Because 111b we have made it as 1. 2998,000 remainder 5. 5 minus b mod 11 we found. And when 5 minus b is divided by 11, the remainder should be 0. That means b is equivalent to 5 mod 11. This is solution for b. Now, that implies b is equal to 11 into m plus 5. The meaning of this is this. Now we substitute this value in the original equation. Original equation is 11a is equal to 2998,000 minus 11b. 11a is equal to 2998,000 minus 11b. that is equal to 2998,000 minus 111 into 11m plus 5. That is equal to 2998,000 minus 111 into 15, 111 into 5, sorry, 2997,445, 2997,445 minus 11 into 111, 11 into 111, 1221m. Therefore, A is equal to 2997,445 minus 1221 divided by whole divided by 11. Two nine nine seven double four five. When divided by 11, it is 272,495 minus 1221 divided by 11, that is equal to 111 m. That implies A is equal to 272,495 minus 111 m. B is equal to 11m plus 5, which implies A plus B is equal to 272,495 minus 111m plus 11m plus 5. That is equal to A plus B is equal to 2772495, 272,495 plus 5, 272,500 minus 100m. This is the value A plus B, where if m is equal to 0, this implies A plus B is equal to 272,500. And A is positive and B is positive. For A to be positive, A is equal to 272,495 minus 111m. For A to be positive, for A to be greater than 0, an integer value, then two seven two four nine five minus 111m should be greater than or equal to 0. Then 272,495 should be greater than 111m. That implies m should be less than or equal to 272,495 by 111. 272,495 divided by 111, that is 2454.9. But we wanted values in integers. That means m should be less than or equal to 2454. The maximum value of m is 2454. M cannot be less than 0 because B is equal to 11m plus 5 to be greater than or equal to 0. That implies 11m should be greater than or equal to minus 5. That implies m should be greater than or equal to minus 5 by 11. That implies m should be greater than or equal to minus of some fraction like this. That implies m should be greater than or equal to 0. That means 0 is less than or equal to m is less than or equal to 2454. This is the range in which m should oscillate, and a plus b is equal to 272,500 minus 100m. 272,500 minus 100m implies a plus b will be in the range. M is 0 means 272,500. M is equal to 0 and a plus b is equal to 272,500 minus 100 into 2454. 272,500 minus 100 into 2454, that is 27,100. That implies 27,100 should be less than or equal to a plus b. A plus b should be less than or equal to 272,500, the integer values. This is the final answer. And this type of questions being asked in JEE Mains and also JEE Advanced, please try to understand them. And the heart of the solution is b is equal to 11m plus 5 you should get. And second is we will be getting an equation of a in terms of m, which is taken from the equation of b, and we got the value of a plus b. The whole question and the answer involved many concepts, so that this is also very important concepts which you should develop on the basis of the question given. A plus b is equal to some 100 into k. From there we got the answers. If you see here, a plus b is in the range of 27,100 to 270 to 500, and it should be some 100 into k, multiples of 100. Then k you can decide, k value is from 271 to 270 to 2725, which implies 271 is less than or equal to k is less than or equal to 272. If the question is asked this way, to find the range of the k, you can find this way. To find the range of a plus b, you can find this way, because a plus b we have we came to the conclusion that it should be in the multiples of 100. It should be in 100k. K is this range and A plus B is that range. Then ultimately the answer is this one. If you feel there is a value addition because of this lecture to you, kindly hype this lecture, share this lecture, and subscribe to my channel Maths and Science by IITian. The topic functions itself is a very big topic. We will come across many functions. Real valued functions means it is itself a very big topic. It's a real valued discrete function. And the equation can be a Diophantine equation. Diophantine equation. It doesn't only cover the number theory concepts, it covers the algebraic concepts, it covers various concepts of numbers and algebra and inequalities. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture.